Hi, so once again, we're asking the question whether or not a given matrix P is invertible. And in this case, we see a 4x4 matrix again. And so following the lead from the previous video, what we want to do is to find the reduced row echelon form of this matrix. So I'm going to go ahead and define P to be a 4x4 matrix. So let's say minus 3, 1, 7, 4, minus 3, minus 5, minus 1, minus 4, 4, 3, minus 6, minus 2, minus 1, minus 1, 1, 0. And then we want to take its reduced row echelon form. And what we see here is that we do not get the identity matrix. But let's just write down what we do get. We get that the reduced row echelon form of P is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then 1, 0, 1, 0. Alright. So, the last time we saw was that when the reduced row echelon form was the identity matrix, that meant that the matrix was invertible. And what we have here now instead is a matrix whose reduced row echelon form is not invertible, and you may surmise that this must mean that it's not invertible, or it's not the identity, so it's not invertible, but we do want to know why, right? And so let's talk about why it's not invertible. So like before, what we were talking about in the previous video was thinking of the matrices as representing a linear transformation from some Rn to some Rm, and in this case from R4 to R4. So I'm going to take my 2 copies of R4, and this matrix here represents T sub P, right? Now, what we note here, first of all, is that there's a 0 row here, right? And what the 0 row tells you is that this transformation here, its image does not span the codomain. And so if I take all of R4 and I map it via TP, it's not going to hit all of R4. It's going to hit some of R4, right? So you might imagine that this is the only part of R4 that's getting hit. The rest of it is being missed by this transformation. And that by itself rules out the possibility that this transformation is invertible, because like we discussed before, I may be able to send these elements back, but if there's nothing coming to these elements, then there's nothing to send them back to, so there's no function defined in R4 going back. But that's not the only thing. What we also note is that here I have 2 rows that have a pivot followed by some other value. In other words, I have this column here that contains non-pivots. And so what that's telling us is, if we were to sort of augment this matrix a little bit with stuff, and then we would get an augmented matrix here, that if you did have a solution, you would have infinitely many solutions, right? And so that means that for each of these elements here, there's infinitely many right? It's kind of hard to see at this point. But every point there's infinitely many values in the domain that go to that element in the codomain. So if I'm at this point, I'm trying to come back to, I don't know who to send it back to. There's infinitely many candidates. So there's not a well-defined function going the other way either. And so because this function is not one-to-one, or because it's not onto, it's not invertible. And since it's not invertible, the matrix that represents it is not invertible either. So since the reduced row echelon form of P is not the identity, P is not invertible. All right, thank you.